Hey everyone, welcome back. So till now we have covered STL and solved some problems based on STL. So today we are going to start a new topic which is math. Okay, so basically math is very important topic for DSA. Most of the problems you are going to solve, it can become easier using math, right? Most of the time it will reduce your time complexity as well as your space complexity while solving problems. So let's see what types of problem we are going to solve. Okay, first we are going to start with the basic concepts of math, which is very important. Our first is abstract digits, then reverse numbers, prime number, and number of digits, sum of digit, factors of number, prime factors, SCF. So these are basic concepts which we are going to learn because these concepts will be useful for most of the problems. Okay, so let's start with our first concept, abstract digits. So what are digits? 1, 2, 3, 4. The numbers are digits, but for digits we are talking about single number. Okay, if we are talking about 10, it is not a digit, it is a number, right? It is a number. These are digits. So we have a number. Let's take an example, 7, 4, 5, 9. It is a number. Now we have to extract digits. Extracting digit means you have to individually write numbers like this. Okay, so number is not a index based, right? So you cannot iterate over the number and can print single digit at a time. So number is not a index based. What is the way we can extract our digits from the number? So the first method is convert it to string. If you convert your number into the string, right, there is a function to string which will convert your number into the string. Then you can loop over it and then extract your number. Okay, it is going to take a time complexity of big of n, right? If this string is of size n, then time complexity will become n, and also space complexity will be n also, because we are taking extra string. So it will take space complexity of big of n. Okay, let's first write the code for this logic. So first we have our number. Okay, now we have to convert this number into a string. So we will declare string str equals to string of n. So we are converting number to the string. Then we can loop I less than str dot size, right? Because we are counting how many digits are available in the number or string. Then I plus plus, then we can easily print. Okay, so you are printing the digits. These digits are in the form of character, right? Because you are picking a single digit from the string. So whenever you are picking a digit or character, right? Because our definition of a string is sequence of characters. So if we have this number 7459 and it is in the form of a string, so these are not a digits, these are the characters. Okay, so if you want to convert to the digits, means you want to convert to the char to integer, right? You can do a typecasting, or there is simple method. You just have to do a minus of digit of 0. Okay, this will convert your character to the integer. Now let's talk about the time complexity and space complexity. Here you can see we are using extra string and the size will be string size, right? So we are talking string size of m, so we can say our space complexity will be m, and we are also looping m times, so our time complexity will become big of m, right? And also we are using inbuilt function. So you can see we are using more space and taking more time. So now we have to improve the solution, means we can make this big of 1, right? And also can improve this to the big of log m. Okay, so now let's move to our improved solution, means better solution. Okay, so first let's write our number 7459. This is our number. Okay, if you do a modulo of 10 here, modulo give the remainder, right? So what will be the the remainder of this number. If you try to divide it, 7459 divided by 10, so it will be 7 times 70, then 4, 5, 4 times, then it will be 5, then 9, then 5 times 10, 50, then 9. Here you can see our remainder is 9. Okay, so we can say this number modulo 10 will give me the remainder of 9, right? So now what will be the value of n? It will still be 7459 because modulo sign only gives the remainder and does not make any changes into the number. So we have extracted the 9, so we have written 9 separately. Now we have to remove 9 from here, right? If we can remove 9 from here, then we can move to the next digit. So if you have this number and if you divide with 10, this time we are not talking about modulo, we are dividing it, then it will become 745.9. and if you take it, or C++ will automatically round off to the 745. So our new number will become 7459 divided by 10 will become 745. Okay, now we got new number. Now if we take 745 and again do a modulo of 10, it will return me 5, which is this number. Okay, and you can divide same number with 10, it will return 74. Okay, then let's take this number 74 modulo 10, it will return 4. Then 74 divided by 10, it will return 7. Then 7 modulo 10, it will return 7. Then 7 divided by 10, it will return 0. So here you can see initially we first extracted 9, then we extracted 5, then 4, then 7. So you can see these are our digits. Okay, we are using modulo to extract a digit as well as we are dividing same number to update that number. Okay, so we are taking here, okay, and here. So we are doing same thing, means we are repeating same thing. We are doing modulo then divide, so we are repeating. So we can use loops. Now can we use for loop? If we are going to use for loop, then it will be complex to write a condition, right? Because in this case we can say our loop may be running for a 1 time, 2 time, 3 time or 4 times, right? Because we have here 4 digits. If we have more digits, then it may be running for a longer number of times. And also this is an integer, right? This is an integer, so you cannot use size function, so you don't know how many digits are in there, so you cannot write for loop, right? Let's say if you try to write for loop, for this it is a 4. If you take different number, you are not going to change it to that number again, right? You cannot change in the code. You can change as a developer, but if a user using your code, he does not know what is happening behind the scene, so you cannot use for loop here. So we have an option of while loop. Okay, so while loop we can write a condition that until our value of n is greater than 0, then we will keep running our loop. Okay, let me first write a code, then we will dry run it. So first we will declare our n. Okay, then we will run a loop. We will write a condition n greater than 0. Okay, here you can see at the end our n is becoming a 0 after dividing the number. We are taking this condition that our n becomes 0 or less than 0. In that case we can stop our loop. So this condition is true, means our loop will keep running. Okay, now we have to find a remainder. So I am declaring one more variable and doing a modulo 10. Okay, so you have a number here 7459, okay, which is greater than 0, and in the remainder we are 7459 modulo 10, it will become our 9, right? So remainder is storing 9. Then we can print this remainder, then here spaces, then our value of n is still 7459. So now we have to update that value to the 745. So that means we have to remove this 9. So we will do a n equals to n divided by 10. Okay, this will update our value to the 749. Now loop will continue and compare. Is 745 greater than 0? Condition is true. Then it will again find the remainder, which will be our this time 5. Then it will again update our value and it will become 74. So it will keep running until our n becomes 0. So this is the code for extracting digits. Okay, this is important concept. We are going to use it most of the time. Now let's talk about the time complexity and the space complexity. Okay, so let's first look at the space complexity. Is there any variable which is taking extra space? No. So our space complexity will be big of 1. Now what will be the time complexity? Big of n? No, right? You cannot say that n numbers is equivalent to n number of digits. Okay, means you cannot say if a string have a size of 10, is it equivalent to that number? Okay, so what will be our time complexity? We are dividing n by 10, right, again and again for the kth time, and our stopping condition is when n becomes less than equals to 0. This is our stopping condition. So this will be equivalent to log base of 10 n. Okay, so our k is equivalent to log base 10 of n. You can see my video on time and space complexity where you will be able to see how this is coming. Okay, I am not going to solve, but you are going to get in a log base 10 of n. So simple rule, whenever your iteration is happening while dividing with some number, then it will always be in a log. Okay, so our time complexity here will become log base 10 of n. Okay, so here you can see our log n is smaller than log m, and also big of 1 is smaller than log m. Okay, now let's write code for both of the methods. I hope you able to understand it, because it is very important concept. If you are not able to, go back and play it again, and also dry run it on different numbers. Okay, you can take any numbers and try it on yourself how it is working. Okay, now let's code it up. Okay, let's create our new file maths.cpp. then we will start our include bit slash std c++.h, then using name space std, then our int main, then let's first declare our number. Okay, now let's convert to the string, then str equals to string, then let's write a loop I less than str dot size. Okay, we will run our loop from 0 to str dot size, then I plus plus. Okay, let's print it here, str of I. Okay, if we print like this, then it will print characters. If we want to print numbers, we will do a minus of 0. Okay, this is a minus of character 0. Okay, because it is in a single bytes. Then okay, now let's run our program. So our input is 7459. So here you can see it printed the out, and our numbers are space separated. Okay, so that means we were able to extract our numbers. So now let's write our improved code. Okay, so in that case we are not going to use this, also this. Let's write while n greater than 0. Okay, then int of remainder, then n modulo of 10, then we can print here. Okay, then we will update our n. Okay, now let's run our code, then 7459. Here you can see it is giving me the digits, but the digits are in the reverse order, right? You can see our previous output, it was giving 7459, but this time it is giving 9547, because in this case we are looping from the start 0 index, right? Because it is in the string. But here we are extracting digit from the back, because first we are extracting 9, then we are extracting 5, then 4, then 7. So that's why it is in the reverse order. Okay, so we will see in the next video how we are going to use these digits to solve our problem. We can take a benefit from this reversed digits also. Until then, thank you everyone, have a nice day.